Okay, this is lesson 21-1 on special right triangles, specifically 45, 45, 90 triangles. Um, they tell us that we're looking at a quilt, and the quilt is made up of sewing small fabric pieces sewn together to create a pattern. This is called the friendship star. So it says the friendship star quilt block contains 5 small squares and then 8 triangles. Identify congruent figures in the quilt block and explain how they are congruent. So I did something a little bit different. I went through here and said, okay, well, how many different shapes could I find? This shape right here is the one 9x9 square. And then it's divided up into 9. There's 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 1x1 squares. Some of those squares are divided up into triangles by having a diagonal right there. There's 4 triangles that have a pattern, and there's 4 triangles that are solid. So there's a total of 8 triangles. There's also 4 2x2 squares. So the 2x2 squares are like here. There's one. And then here's another one. And so forth. So anyway, those are some of the shapes. How do I know that they're congruent? Well, because they're squares. And they tell us that it's squares. How do I know the triangles are congruent? Because they drew one diagonal, and that diagonal is like a line of symmetry, which means that the triangle on this side is congruent to the triangle on that side. So if that's the line of symmetry, then the triangles are congruent. So classify the triangles in the quilt block by their angle measures. So what do they have? They have a 90-degree angle because there's that angle right there that's, part of the square. That's a 90-degree angle. So we know that it's a right triangle. And the other 2 angles, I think that's going to be a question coming up. Classify the triangles in the quilt block by their side lengths. So, what do we know about? Let me clean some of this up. Let me clean this up. What do we know about this triangle right here? Well, this side is the side of a square, and this side right here is also the side of a square. So that means that these 2 sides are the same length. What do you call a triangle that has at least 2 sides that are congruent? That is an isosceles. So all of these are isosceles right triangles. All the triangles in this picture are what we call isosceles right triangles. What are the measures of the acute angles? Explain your reasoning, okay? So I have a square. That square has a diagonal. That diagonal cuts these 2 triangles into 2 congruent shapes. So that means that this angle right here is equal to this angle right here. If that really is a line of reflection, then these 2 angles are congruent. Now we know together that it's a right angle because all 4 angles in a square are right angles. So if I take a right angle and I cut it into 2 equal pieces, you get 45 degrees. So it says, we've got the student council is designing the different quilt blocks, and they want us to find the length of the leg in inches. So this quilt right here is a 9x9. So, well, that's kind of the length of the leg is 9 inches, right? Because let's draw the square over here. If this is a 9 by 9 square, then that means, and then I take and I cut it into two parts, then that means that this leg is still 9, and so is this leg. So the legs of the triangle are all 9, and the legs of the triangle are 9. So the length of the hypotenuse, well, we've got a right triangle. Doesn't matter which one you choose. Let's choose this right triangle. We know one side is 9. We know the other side is 9. Now we have to do Pythagorean theorem to find this side. So leg squared plus leg squared is equal to the hypotenuse squared. So that's 81 plus 81. That's equal to the hypotenuse squared. Add those two numbers together, and I'll get a 2. I think that's 162. 162 is not a perfect square. Uh-oh, I did some math here that I didn't say. Let me go ahead and put the square right there, and then we'll take the square root of both sides. So I added those two together. It's 162 is equal to the hypotenuse squared. I got to figure out what the hypotenuse is, so I take the square root of both sides. 162 is not a perfect square. But it is, if you factor 162, you find out that it is 81 times 2, and then 81 is 9 times 9. So this becomes, those two, that pair of 9s becomes an outside number. And then we have the 2, this 2 right here, left inside. And that's equal to h, because the square root and the square cancel out. So the length of that hypotenuse is 9 square roots of 2. And they want us to compare the ratio. They want us to write a ratio of the hypotenuse to the leg. So we're going to do 9 square roots of 2 over 9. And when we do that, we can simplify the 9s, and it just comes out to the square root of 2. So if we do it again, we do the same thing again. What number is going to change? Well, it's not going to be 9 anymore. It's going to be 15. So we'll have 15 here, and the diagonal, that'll be 15 inches. When we do the Pythagorean theorem, we'll get 15 squared plus 15 squared. That's equal to the hypotenuse squared. I think that's 225 plus 225. That's equal to hypotenuse squared. Add those two together. It'll be 450. Again, I did it again, didn't I? I did the square root too soon. The square root of 50 is not a perfect square, but it will factor. It's 225 times 2, and then 225 is 15 times 15. So that pair comes on the outside, and the square root of 2, which is right there, stays on the inside. So your hypotenuse turns out to be 15 square roots of 2. Do a ratio of the hypotenuse, which is 15 square roots of 2 over 15, and it comes down to the square root of 2. So we got to work backwards here. If this is the length of the triangle leg, then this is a 1 inch by 1 inch. Now, I don't know about y'all, but I've recognized a pattern. When it was 9 inches, my hypotenuse was 9 square roots of 2. When it was 15 inches, my hypotenuse was 15 square roots of 2. I don't know if you need to do another one to see if that's a pattern or not, but I don't, because I already know it's a pattern. So when you write this as a ratio, you get the square root of 2 over 1, and it's just the square root of 2. This is 1.5, so this will be 1.5 times 1.5. That's how big the square is. This is going to be 1.5 square roots of 2. You want to keep doing the math over here. So you got all that. Just do it the same way. Just change your numbers. And then this will be 1.5 square roots of 2 over 1.5. Those will cancel out, leaving me a square root of 2. There's a pattern going on here. 2 by 2. It's a 2 by 2 square. The legs of the triangles are both 2. The hypotenuse is 2 square roots of 2. And the ratio of the hypotenuse to the leg is going to be the square root of 2. Okay, now this time they tell me, look, the hypotenuse is 6 square roots of 2. So based on all of these other things right here, the number in front of the square root of 2 was how long my legs were. So this must be 6. And if this is 6, then this was a 6 by 6 square. And the ratio is the square root of 2. Okay, now all of a sudden they throw me a hypotenuse that doesn't have a square root of 2 in it. Does that mean I can't do it? No, you can still do it. You're just going to have to think a little bit and maybe do a little algebra. Okay, so we normally have said that whatever this side is, and this time we don't know. So just for a second, can I call it x? You know me, I like to work with variables, and x seems to be my favorite. So this is normally x square roots of 2. This is what's normally in this box right here. But this time, what we expect to be in this box isn't there, but 4 is. So what that means is that this number over here must not be just a plain number. It must have a square root in it, because when we multiply this number times this square root, they go away. So how do we find out what that number is? Come on, you guys, this is just an algebra problem. I know that some number times the square root of 2 is supposed to give me 4. So what do I normally do in an algebra problem when I have an unknown? X times the square root of 2 is equal to 4. So how do we undo the multiplication right here? You're exactly right. You divide. So this becomes x is equal to 4 over the square root of 2. Now you're supposed to know that you cannot leave a radical in the denominator. And if you can't leave the radical in the denominator, you're also supposed to know how to rationalize a denominator. This is called an irrational number. So we need it to be a rational number. Irrational because it has the square root. It'll be rational, the square root will be gone. So the way that you rationalize a denominator, and if you don't know this, send me an email and I'll send you a video that explains it in more detail and gives you some more examples. I'm going to multiply top and bottom by whatever that radical was. And that's going to make it go away. So on the top, I've got 4 times the square root of 2. And on the bottom, I've got the square root of 2 times the square root of 2, which is just 2. And then because they're both just integer values, the 4 and the 2 will reduce, and that ends up being 2 square roots of 2. So that's what this over here is. This is 2 square roots of 2. And now if you multiply, let me go back up here. If you multiply 2 square roots of 2 times the square root of 2, you multiply this 2 times that 1, that's 2. And then you multiply the square root of 2 times the square root of 2, that's 2. And you multiply those two numbers together and you get 4, which is what they said it was. All right, and so now they want the ratio of the hypotenuse, which is 4 over the leg length. And the leg length is 2 square roots of 2. And if you simplify this the right way, it simplifies back down to the square root of 2. And this one was a 2 root 2 by a 2 root 2. That was how big the square was. All right. What did you notice? What patterns did you notice in the table? Well, I noticed that the hypotenuse is just the leg length times the square root of 2. Suppose that you were only given the length of one leg of an isosceles right triangle. Can you find the other ones? Write a verbal rule for finding the other ones. Yes. This is the leg. I can take the leg and multiply the leg length times the square root of 2, and that will always equal the hypotenuse. That's what I learned up there. So that's as verbal as I'm going to get. Multiply and equals, it's okay to use those as symbols. It says, let L be the length of the leg of any isosceles right triangle. Use the Pythagorean theorem to derive an algebraic rule for finding the length of the hypotenuse. Okay, so L squared plus L squared is equal to H squared. And then when we have L squared plus L squared, isn't that just 2L squared equals H squared? Yes, it is. How do I solve for H? You take the square root of both sides. The square root and the square cancel out. This needs to be separated because we have the square root of 2 and we also have the square root of L squared. The reason you want to separate it is because that square root is going to cancel out with that square, leaving you just that L. So you'll have L square roots of 2 is equal to H. Isn't that exactly what we just wrote right there? That the leg times the square root of 2 is equal to the hypotenuse. Pythagorean theorem, we solved it. The L, the leg length, times the square root of 2 is equal to the hypotenuse. So the big idea here is that special right triangles are supposed to be shortcuts. The special right triangle formula, it's supposed to be a shortcut. So you should be able to work these problems faster than if you had to do the Pythagorean theorem. But remember, if you have an isosceles right triangle, you can always work this with the Pythagorean theorem, because if you know the hypotenuse, if they give you 2 legs, you can always use, if they give you 2 sides, you can always do the Pythagorean theorem, because if this one right here is x, then so is this one. And this one right here, and I'm not going to do anymore, I'm going to let you do these, but I'm just showing you that you could do the Pythagorean theorem. I don't want you to do Pythagorean theorem. I want you to try the 45-45 formula that I just gave you, which is the leg length is times the square root of 2 is equal to the hypotenuse. That's the formula that I want you to use. Take whatever information that you have, plug it in, and find what you don't have. But if you get stuck, you should always be able to go back and do the Pythagorean theorem, because if they give you a leg length, then you've got leg squared plus leg squared equals hypotenuse. If they don't, then the missing side is x. Well, the other missing side is also x, and then it's just x squared plus x squared equals that squared. Now, this is really going to test your understanding of working with radicals. So if you find that this is what you don't understand, please send me an email and let me send you some videos on just working with these radicals, because this is not the geometry. The geometry is this formula over here. This is just, numerical manipulation. It's like fraction rules. Fractions have rules, radicals have rules, and so you just have to learn how to combine those. So I'm going to go ahead and stop the video, and at the beginning of my next video, we're going to be checking your understanding numbers 5 through 9. Okay, so good luck with that.